In this video, we are going to introduce a new package, which is Seaborn. So we are going to import Seaborn and use it for analysis. So let's go for it. I'll continue with the copying and pasting and explaining the code. That will help us save some time. So what we want to do here is we are going to import Seaborn and we are going to give it the alias SNS so that we don't have to be typing Seaborn all the time. If you do not put as, then you have to be typing all of this. And we are also going to import PyPlot, which is in Matplotlib, and we are going to take it as PLT. And here we want to create an economic data. Here we have different categories. We want to start with a count plot. So if you have to count, if you are looking for the if you have to count each of these different categories, you can see employees appear 1, 2, 3. Unemployed is 1, 2. So if you have to plot this, you will have two bar charts. You'll have two bar charts. One will have 3, the other will have 2. But this will do it for you. So we are going to keep using PLT. So we just so actually this is all what we need. But we chose to put this so that we can have PLT, we can control the size of the figure. So you could choose not to put this and only use this. However, when we have to look at an advanced lesson of Seaborn, we'll see how to use Seaborn to control the shape or the size of your object. But I want to stay consistent with what we've been doing here. We've been using PLT, figure fixed size. I want to keep that so that you really master it before we add some more. So we'll keep the PLT things in the context of Seaborn. So here, of course, I have the size, and this is what we are doing. We are just presenting the data, and we say go into that data, count the different categories, and present the frequency of the different categories. That's all. A count plot simply goes and count what's there and presents the frequency distribution of it. And of course, this is the title, this is the X label, Y label, and you are given the command show. So I'll go for Shift Enter and we'll see how it looks like. So there you go. Well, if you want your graph to be a bit taller, you can just manipulate the numbers which are here. Okay, 2. So the second one will determine how the y-axis is. The first one is simply your x-axis. So I'll keep it like this because it just helps my thing not to look too big, and I don't like it when it looks too big. So it's all about personal preference. Now let's move on to the next chart, the next Seaborn chart. We are going to take a look at a bar plot. Now here we basically have different countries, and we have the GDP. Remember, this is just fictional data. We have the GDP of those countries. And for a bar plot, we are simply going to, remember, this is the only code from Seaborn we are using. So you simply tell Seaborn, for a bar plot, you have to tell it what is your x-axis and what's the categorical axis. So, well, the categorical axis and your numbers. So the x-axis always has your categories, okay? Except you are trying to produce a vertical bar plot. If it's just a horizontal bar plot, then you present your x-axis as the different categories. Here we have the category of countries, and here you have your numbers. Now I'll run it, then I'll also throw in the figure thing so that you can see the difference when you apply it and when you don't apply it. So I'll do Shift Enter, and you see it's pretty large. I don't want it to be like that, so I'll just come here and put that size, and I'll do Shift Enter, and you can see how small it is. So this helps you to control what you are doing. So that's it for bar plot. Let's take a look at what we can do when it comes to a histogram. Now here we've given data, synthetic data for histogram, for unemployment, And of course here we want to put the size of it, so we'll always come and get it from there so that you remember. I encourage you to type it so that you stick this in your memory. So this is the only code you need from the perspective of Seaborn. If you want, you can forget about all the other things. This is enough to give you your chart. However, it's good when you label your axis. You have your title, your y-axis, your x-axis. It's a nice thing to do. So all we need is to give it the data, and it's going to give us the distribution of this data. That's just what your histogram is. When we saw histogram, actually, if you want, you can add more. Things here. So you can add the bandwidth, you can add the number of bins, and so on. Here we've not said anything about bins, so it's going to automatically generate the bins. But if you want, you just put a comma and put the number of bins. So shift and enter, and there we go with it. So if, for example, you don't just want 4, you want, let's say, 6 bins. In other words, 6 different classes. I'll just put a comma and say bins equals 6, shift enter, and you'll see it's going to split it into 6 equal bins. Okay, I'll just leave it there, but there are more things. If you just bring your cursor and put it here, then it's definitely, generally, it's going to suggest the different options you have. Okay, let's move on with the next one. So we are going to take a look at a kernel density plot. So this is basically all you need to do. You need to use the KDE, the kernel density plot, and we are presenting our data. Of course, this is simply the size, and we want it to have a shade. You can put shade false, so you can just let it do the default without putting any shade, and all the rest is the usual blah blah blah. So we run with shift enter, and of course it's going, so here you have the shade, the sky blue. This is your kernel density plot. It simply shows the distribution of it, and of course we are dealing with the unemployment data we had earlier provided here. So it's using that data to simply show you that the highest frequency occurs around 3.8 or 0.9, and here you have the lowest frequency and the highest frequency. So, well, let me rephrase it. This is your middle score. So your middle score appears around here, or your median score appears around here, your highest and your lowest. So that's a bit of what it does. So let's throw in some more. We'll see a series of them. Here we are presenting data for inflation. If you want, you can just skip it, but we will soon look at inflation and unemployment. That's why we put both of them. We want to do a scatter plot. Now a scatter plot is there to show the relationship, it's a correlation graph. Basically, it shows the relationship between inflation and, here we are using GDP growth. Now, GDP growth, let's take a look. I think we had already defined it earlier. If we had not defined it, then I'm going to copy unemployment and define it as, so I'll come here and change and just provide some data here. So I'll call this GDP growth so that it can use it. Now we have to make sure it's the same length. So here we have 1, 2, 4, 5, 6, 7, 8. That's awesome. So it's the same length. So it's able to plot it. And basically you need just this. You provide your X or your Y. Anyway, whatever you present as X or Y doesn't matter. You can flip them, but you need to provide the two variables you want to study how they change across time. Okay, so let's run the graph, shift enter, and there we go. So we see we see the relationship between the two of them. For example, here, when this one inflation is 1.5, GDP is 5.2. So inflation is 1 point something, GDP is 5 point that. So it's just putting the points on this for you to see if there's a pattern in how they change across time. So let's move on to the next one. I want to take a look at the so-called box plot. So the box plot is extremely important because it helps you understand, well, at times they call it a 5 summary statistic graph, because it shows you the minimum, maximum, it shows you the outliers, it shows you the different quartiles and the mean or median value. So all you need to do is to put sns.boxplot and you present your data and it's going to do it for you. So shift enter, and here we go with our box plot. Now, why do we have two box plot here? The reason is simply because we've already defined GDP growth in the previous chart. This is your GDP growth. And in addition to that, we have another data set. So this is the second data set. So you have for this data set and this other list. So these are two Python lists. So it's giving it to us for each of them. That's just the reason. Okay. If it were one, then it will just do it for one. So let's go. This graph doesn't look so good, so we could slightly increase the size. I'll just put 4 here. Yeah, this looks a lot better because you can a bit more clearly see what's good. So you have the max, min, you have the median, you have the third quartile, the first quartile, and of course the second quartile. And if you had any outliers, you'll see it very clearly here. Okay, let's go to the next one. We'll take a look at the so-called Vowlin plot. So same thing, you can see SNS is really easy to use. All you need is to provide the name Vowlin plot and you provide the data, and that's it. It's going to give you the distribution of this data using another approach. So here you go. So why do we have this? So here you have the same data set we are using here. So it's the GDP data, you have this and this, so it's giving you a value. So it's basically the same plot, but presented a bit differently. Okay, so here you can really see where you can see the middle values of the distribution. You can see the higher end and the lower end of the distribution. So it's just playing around this, okay? But it's just presenting the information slightly differently. So for that, I'm going to put 4 here. So that we have a much more interesting view. Okay, let's take a look at the next one. In this one, we want to play around with the pair plot. And here, basically, I want to, okay, I'll just import Panda because we had import as PD. So we want to define all of this GDP, inflation, and unemployment. Here we want to create, so we are simply creating a data frame of GDP, which is given as GDP growth. So the GDP will use the value of GDP growth. We've already defined it up there. Here, inflation, we had defined it. Unemployment, we had defined it. So GDP growth, you have it right here. GDP growth, it's the value we define here. You have inflation, and if you go up, you'll find that we had also defined unemployment. Now, it's true that the values are somehow similar for unemployment and GDP growth because we did a copy and paste, but it doesn't matter. So this is a list, this is a list, this is a Python list, and we are giving names to it, and we are producing the different pairs here, and we want to use it to create a data frame. Now this data frame, if you want to see how it looks like, so if I want, let me just get this off for a minute and do data dot head. Well, I'll just do data, okay, shift enter, and here we go. You can see this is how the data looks like. That's why I said the GDP and this one, they just look very similar because I did a copy and paste. Okay, so now I'll come back and put back what I had initially taken away. We want a pair plot where we see this data series. Shift enter. And here we go with a pair plot. So what does it do? You can see unemployment, inflation, GDP, and here you have GDP, inflation, unemployment. You can see that wherever you have, so you have a series of scatter plots, and they are, so basically where you have unemployment and GDP, you have a straight line. Where you have GDP and GDP, you are just having a distribution. So it's not repeating things. GDP and GDP, you have the distribution, you have the distribution, you have the distribution because you have the histogram there. And when you come to the other ones, you have the scatter plots. So that's just what it does in terms of for your pair plot. So if you want to study the relationship between variables, you can easily use this to do that. That's when you start entering the field of correlational studies. Let's move on to the next one. Here we want to create a correlation matrix, and of course we want a heat map, which is a very interesting type of chart. It's similar to this, but it's quite different. It just shows, well, you'll see it. So we are presenting the same data set we had initially presented here. We are using the same data set to make sure we can see the different information. Now we want to create a correlation matrix, and we now use that correlation matrix here. So a heat map, generally the first step is get a correlation matrix using the dot core. Okay, your dot core, and from the dot core throw it in here. And then we want annotation. In other words, we want it to give us all the labels and the type of color we want a cool warm. You could of course use other colors, but in this case we've chosen the cool warm color. Let's go for it. Shift enter, and here we go. So this is basically, this tells you when you have this extreme red, you are dealing with a very high correlation, and when you're here, you are dealing with a low correlation. So if you want, you can increase the size of this by changing that. I could just say 5, and I could make this 4, shift enter, just to clearly show what it is, so that the names you have here, this is unemployment, GDP, it has a perfect correlation. You can see that here. So it's a correlation of 1 because it's the same data set. However, GDP and inflation, this is what you have there. So it's a beautiful tool when you are trying to compute, to study the relationship between economic variables. Not just economic variables, any two pairs of variables. So we will revisit some traditional charts. We want to take a look at the line plot. So after taking a look at this, where we have the joint plot, of course, we created a data frame for GDP growth, unemployment, and it gave us this. We want to take a look at our last chart for the moment. We are going to keep using the skills as we move on in our learning, and everything will become very easy. This is an interesting one. So we have a list of GDP growth, and we have the years, And now we want to create a data frame, and in this data frame we basically have year, GDP, and we have country. Now it's important that the data should be of the same size. If you count, it goes from 2000 to 2007, so you are talking of a length of 8. So country, given that we are going to have GDP growth year and country should also be 8. That's why we are just multiplying this by 8. Okay, so if we want, we could put a third one, and that time you have to make sure you multiply it in such a way that, well, you can just put 4 here and multiply it by 2. You can do something like that. Now, this is the important thing here. So the facet, this is what it does. You say facet grade, you give the name of your data set. The column will be the countries, and we have a wrap of 2. In other words, you want 2 countries per line. So let's run this code and see how it looks like and try to break it to better understand it. So basically this is what it's doing. It has plotted USA and China. So if, for example, we say, okay, I'll put this in. And this, I'll multiply it by, so let me send this to the next line so that we can see what we are doing. I'll multiply this by 2, basically. Yeah, so basically we can add some more countries, so we will multiply it by 2 so that it's going to just be 2 countries. So we should expect to have, given that we've defined it here, that we want 2, the column wrap should take only 2 countries per line, and the line should be the countries, so we should have 2 for each line. But you see, the data will not look like, we won't have 1, 2, 3, 4 points. We'll just have 2 points per country because we only have 8 of that. So let's run our code now and see if it works. Shift enter. And there we go, country. So you have the different countries, and that's it. So you can simply use the facet grid to run your code like that. So that will be it for this lesson. Next one, we will go back and start playing with data. We'll create synthetic data, run some analysis, and after that we are going to start using real data from the website of Statistics Canada, analyzing things like the population growth, the consumer price index, unemployment, employment, real GDP, and so on. And after that, we are going to introduce some statistics and machine learning for economists.